But first of all, let me start by saying how beyond grateful I am to be here, because this is actually my first talk ever in a psychedelic conference, and for that being breaking convention, wow. Really, actually, I hope that I don't disappoint you by putting you in the lab, but I see that people are interested into the biology of addiction and to how materialistic medical science is. And as a humble neurobiologist that is just on the second year of a PhD, what I'm hoping that we can do, all the psychonauts, scientists, or whatever, is to bridge exactly that. And although it's difficult to bridge all your powerful experiences into neurobiology biology and neurosciences, I really hope that I will contribute just a little part into bridging, into exploring another language to put this mystical experience and our insights into a world that Western medicine will understand, and we can persuade that there are other ways to do that. So, without further ado, I'm indeed doing my PhD in Charles University under the supervision of Dr. Palenchek. And it was a really great opportunity for me because my primary goal was to study psychedelics, but also addiction. And I was given the chance to do both there. Oh, and I changed my slides. And originally I was going to, so I started off by a cocaine model. I work with rats. And my first two experiments was with psilocybin and ibogaine. Originally it was in the program psilocybin, but I hope you don't mind to share with you some of my first ibogaine data as well. And so, yeah, this is just my cheesy way to say thank you very much to all those, actually the pioneers of the field, who set the stage for us to be here today and who have been a source of inspiration, fueled our motivation. So to all the great teachers that came before us, a big thank you. And so, psychedelics, no need for introduction here, of course. I'm just going to point out that there is no common line when we come to classify them. And we can do that by the subjective experiences that they induce, or we can do that by the chemical structure or their pharmacological profile. And focusing today on psilocybin and ibogaine, well, psilocybin, because it is important for us in neuropharmacology and especially in drug addiction, because we have drug interactions, systems that crosstalk. And so psilocybin belongs to the serotonergic hallucinogens. It acts primarily through the 5-HT2A receptor, while ibogaine, ibogaine is what we call a dirty drug. And I'm saying that with much love, of course. But it seems to have an antagonistic activity on the NMDA receptor, like ketamine. It also has a high affinity for the kappa opioid receptor. On the other hand, it blocks mu opioid receptor. It inhibits the monoamine transporters, so just as MDMA. So there's quite the cocktail there, and maybe the secret recipe, I don't know. And we can all agree that psychedelics seem to be very effective, though. They seem to work across a range of psychiatric conditions, and their effects seem to be long-lasting, rapid, well, hard to ignore, right? And you see here the common suspects: depression, PTSD, OCD, and of course, addiction is among them. Because actually, these all share some fundamentally common characteristics. They seem to all present, well, First of all, the trauma part, of course. But they all present these rigid patterns, these repetitive loops, this feeling of stuckness, low entropy, as you know. They're all low entropy conditions. And, well, oops, pardon. Let's set the stage of addiction then. You very well know it's a chronic relapsing disorder. It starts off by compulsive drug use, loss of control over time, and vulnerability to relapse. And neurobiologically, it is usually described as a 3-stage disorder: binge intoxication, when there's this reward seeking; withdrawal, negative effect, when the drug is not there; and the 3rd stage, preoccupation, anticipation, or craving, where the drug dominates thought and behavior. And this is not just behavioral, it's biological, in the sense that there are certain brain areas that dominate each stage of those. And if you're going to remember something from today, probably should be, well, it's all about our reward system, dopamine system, interplays with other systems, of course, but the nucleus accumbens, you'll hear a lot when we talk about addiction. It is the core of our reward system. It takes dopamine from the ventral tegmental area, which all project to the prefrontal cortex. It's our decision-making, our self-control. And of course, there is memory and the emotional associations in hippocampus and amygdala. Those are the parts that fuel the power of cues to trigger relapse and to trigger craving. How did we get all these ideas about psychedelics in addiction? Well, I think Anne mostly mentioned everything. I was going to say that it probably all started by B. Wilson and the first LSD studies, so I'm not gonna stay there. And of course, Krupitsky's work in the 90s with ketamine, the modern trials then with psilocybin and ibogaine. There are a lot of trials coming on. I have a complete list if everyone's interested. And the signals are there, and they are consistent, and they seem to work. Even after 1 or 2 sessions, psychedelics seem to decrease craving, withdrawal symptoms. They have high rates in abstinence in the studies that use long follow-ups. But we really don't know how, right? So, of course, most emphasize the mystical experience itself, how this allows you to revisit the trauma, to change your life's narrative, to reconsolidate memories. But this is also something that is reflected physiologically. We see changes in the brain network reorganization, functional restructuralization. And this goes downstream. This is reflected molecularly into increase of neurotropic factors who facilitate neuroplasticity. There's all receptor system modulation, and probably there's an epigenetic modulation by psychedelics as well. So, yes, no common mechanisms, no simple answer, ladies and gentlemen. It wouldn't be that easy. But as a neurobiologist, this is where my work begins. What happens when you actually remove the therapist, remove the shaman, remove this sentence setting that we so delicately try to design for our trials? So we take our insights, what happens to humans, and we work backwards. We're trying to create animal models of the disease. And when it comes to addiction, our most common model is intravenous self-administration. So what does that mean? Basically, you take the rats, or the animals, I use rats, and usually rats are used, and you surgically implant them with a permanent catheter where they can self-administer themselves with a drug. So you put them into a chamber, and they learn by pressing the lever, they can take a reward, a drug. And this is paired by a light or a tone. So basically Pavlovian training. So you keep putting them into this chamber day after day until they establish this behavior of addiction. And this phase is called acquisition. And then you remove the drug. And there are multiple ways that you can do that, but the most common is the phase of extinction. So basically you continue to put the rat in the chamber, but this time pressing the lever does not result in reward, does not give them the drug, only saline, and there are no cues. So there's a learning process involved. And they keep doing that until they unlearn this behavior that they had acquired, and this behavior is extinguished, so that's the name. Or you can just leave them cold turkey in their home cage, no drugs, no cues, no chamber, no nothing. And less common, but very interesting, is the contextual withdrawal. There, you put the rats in the chamber, no drugs, of course, but there are the cues. So there is this context that was previously linked with the drug. And I would like to give you a hint here. First of all, this is a phase where, for example, you can test the anti-addictive properties of a drug. And also, we tend to imply that extinction, for example, because it involves these learning processes, it models therapy. And while contextual withdrawal, it might be the best model for exposure therapy. So next comes the reinstatement model. And this is the actual test, the judgment day. And how do you do that? You present the rats to a stimulus, a trigger. And that could be a little bit of the drug itself, so it kind of remembers the high, or a stressor, or their conditioned stimuli like the cue or the light. It's like in humans exactly. We try to model this condition where they see the old friend or the little dark corner or syringe or even a song. And there you can assess the relapse by how many times they press the lever, so how crazy they get by hearing that tone or that light. And in this model, by tackling a few aspects in particular, you can assess in general the drug seeking, the withdrawal symptoms, the craving, how much motivated they are to get the drug. And so this is how we started with our cocaine model and psilocybin. So acquisition, the first stage. And actually, we used dose escalation. So low cocaine dose on the first week, then increase the cocaine dose on the second week. We thought that this might model better the human condition from recreational use to compulsive abuse. Then the rats get randomized into groups. One only gets saline, the second one was psilocybin treated. And our novelty here, if I may say so, was also psilocybin escalation. That was inspired by clinical trials to depression, but it's also kind of a trend for the clinical trials now for addiction. And so we followed the extinction protocol, so the rats kept going in there day by day until they all learned and they stopped pressing the lever. And so on the first day of extinction training, they took a low psilocybin dose, and midway of extinction, a high dose after 5 days. And then when they completed their extinction, there came the cue-induced reinstatement, when we put them in there and presented them with a flashing light and assessed their relapse, measured basically how much time they were pressing. So what did we see? First, there is the acquisition phase, low cocaine dose. You can see the numbers stabilizing. Then you see a slight dip in their presses when we increase the cocaine dose, because it makes sense, right? With less presses, they can get the same high. But then when the use becomes compulsive, the numbers start creeping again. And then the extinction phase. And then we saw some significant difference between the groups. After a day of the high psilocybin treatment, there was a significant difference. The psilocybin group pressed the levers a lot less. So there's a sign of less drug seeking. The effect persisted the following days as a trend. It wasn't significant, but I would like to call this the psychedelic afterglow. And so what happens in the reinstatement? Unfortunately, no significant difference. There is a trend, but still not hard evidence. There is also a nice plot here that actually shows that the psilocybin-treated rats had less variability through their extinction. This means more predictable behavior, less erratic through their extinction training. That might imply a protective role, we don't know. And most importantly, the psilocybin-treated groups never reached their maximum intake again. And because I saw this effect on the next day after their high treatment, and because I was a little bit disappointed and not ready yet to let go of the experiment, I wanted to continue a little bit. So we decided that we will dose them again with a high dose of psilocybin. And my idea was to perform the cue-induced reinstatement test closer to the administration, to see if I could catch a more acute psilocybin effect, perhaps. And also, to be honest, I was very curious to do the drug-induced reinstatement also. I wanted them to inject them with a bit of cocaine and see what happens there. Because if I saw differences with psilocybin, maybe that would imply that it acts through different mechanisms. Unfortunately, nothing. So, no significant effect. Even when we did the reinstatement 2 days after the high treatment. But there's a persistent trend. The psilocybin group always pressed less. And stable behavior, as I said before, less erratic than the other ones. And they did not reach their maximum intake again. And so, ibogaine, we did it exactly the same. By now you know the drill, same exact protocol. We kept everything the same, even the dose escalation in ibogaine. Low ibogaine on the first day of extinction, high ibogaine midway of extinction, then performed the cue-induced reinstatement. And here you can see the acquisition phase having exactly the same pattern. And what do you know? The same pattern again for extinction training. So a significant difference in the first day, 24 hours after they had their high dosing, which kind of persisted as a trend, and no significant effect on reinstatement when they actually saw the triggers. Again, we see the same effect with ibogaine. The ibogaine treated rats, more predictable behavior, less erratic, centered around specific values. So a uniform response. So yes, that all imply perhaps a learning facilitation, because as I said, extinction is about learning. So key takeaways. Neither psilocybin nor ibogaine prevented relapse, so it does not provide strong evidence that they could, this dosing, this timing, this design, they could prevent relapse. But both showed a learning facilitation, perhaps, because they both showed decreased cocaine seeking during their extinction. And also, the treated rats did not reach their maximum intake again. And also a note about our dose escalation protocol, there seems to be some clinical relevance that we can use from preclinical studies. And so, there are a lot of things that we could discuss. I will start by how important we seem timing to be. Timing of the dosing. And the dosing itself, and the context and everything. But across many, many studies, we see this persisting effect of when psychedelics are administered. For example, and I'm sorry I didn't put the citation there, but you can ask me if you're interested. Recent studies, Woodburn, in fear extinction studies, they actually showed a significant effect of psilocybin in fear extinction learning. But that was only when psilocybin was administered during extinction. When they gave psilocybin before the learning or after extinction, the effect was gone. Also, in Benvenuti and colleagues studies in alcohol addiction in rats, same design as ours, also psilocybin did not prevent alcohol relapse, but it did when they combined it with memory reconsolidation. So maybe this whole story, maybe it implies that there's a link there with its primary pharmacological receptor, the 5-HT2A receptor, which is implicated in neuroplasticity, in memory reconsolidation, and facilitates learning processes, which seems to imply that psilocybin is not simply a drug, a passive drug. It needs to act on a learning brain. And that beautifully relates to the, for me, landmark study by Nardu, Gouldolan's lab last year, Nature. Psychedelics reopen the critical window. So it might be correlated with this, that psychedelics indeed open a window to relearn, to reprogram patterns. And going on, well, here's the twist. We get these results from clinical studies, but our preclinical studies show mixed results. And indeed, that brings us to the question whether we are modeling the right thing, right? So this study that you see there actually showed that the rats who showed the best match with transcriptomic profiling of the nucleus accumbens to human cocaine addicts were not the rats that went through extinction, but through contextual withdrawal. So maybe we might be not capturing exactly the human condition. For example, when it comes to cocaine, we might capture the experiments better if we do contextual training, something like the exposure therapy. And maybe we could see different results, psychedelics acting differently. You see, My example, in our experiments, the rats went into their chamber and they learned that pressing the lever was futile. But there were no cues there, so they didn't really unlink the triggers, right? They just stopped pressing. So it's like the paradigm of learning not to fear the thought of a spider versus not to actually fear it when it enters the room. And that brings me to the third point, where whether psychedelics could act differentially. Because we put them all together, and it's one question about if psychedelics could act on the same way or in different conditions. Well, it might be that psilocybin could be an excellent learning facilitator as an add-on to psychedelic therapy, whereas ibogaine may be most powerful in stopping withdrawal symptoms and stopping craving when people need it to survive. And so it's not just academical knowledge, it's matching the right medicament to the right psychotherapeutical context. How are we going to use it? So we're basically standing on this fork. Are we enhancing learning through extinction training, or are we modulating baseline symptoms, craving, and withdrawal? Are we asking the brain to relearn or to forget and create a whole new emotional landscape? Maybe both, I don't know. And as our favorite Alan Watts would say, I'm not trying to sell you on this idea, I would like you to play with it, play with its possibilities. So, future, how are we going to get all this? Well, in my case, I would like to refine the model, next versions of it, adding more groups, some rats doing with contextual withdrawal, some being in abstinence. Also, I would like to create time bins to see what happens when I put them in the chamber for reinstatement, the 5 first minutes, the 10 first minutes, half an hour. Because right now we're looking at the whole session of 2 hours, and maybe there's an effect there that it's being averaged away at the end. And also, we are on our way to do some epigenetic analysis, whether something changes in the psychedelic-treated rats, and already rolling some proliferation and neuroplasticity markers in the nucleus accumbens, which will be also correlated with samples we took to run a microbiome analysis. So, not the end, for sure, just starting. But we might be at contributing something at helping the people out there break the loop. And thank you very, very much for your attention, bearing with me through all this lab work. For sure, nothing of it would be possible without the incredible support of my supervisor, Tomasz. And all my colleagues, my dear colleagues who had been real friends, especially Clara, my superhero, and although he's not in our team, Kasper Wittek from Poland, who helped me with all the surgeries, and the rats, of course, for the wild ride. We spent many nights together. Thank you so much, and I'm open to any questions.